Hi, so today we're going to solve a simple statics problem. So we have a force of 500 Newton in this direction, and we're asked to resolve the forces along two directions u and v. Generally, sometimes we see this question in a more familiar format. So if we have our Cartesian coordinates and we have a force F, right, making an angle theta with the x-axis, right? So we're asked to resolve it along x and y. So in this case, we're all familiar with. So if we want fx, we say fx is equal to f times cosine theta, and if we need fy, we say f times sine theta, right? So this is familiar to us. But what if x and y directions are not perpendicular? They are, like here, we have a 70-degree angle between them. So how do we go about this? It's actually pretty simple. Okay, so the first thing we need to do in these cases is, so let's try to understand this problem first. What he's asking is, what should be the force along this u direction, and what should be the force along this v direction? So we'll call this, let's say, fu fv, right? So that the resultant of this is F equals 500 Newton, and that makes an angle of 45 degrees. Okay, so we need to find Fu and Fv. Alright, so we're going to use something called the sine rule. But in order to do that, the first thing we need to do is make a triangle. If we need to find the resultant of these two forces, Fu and Fv, we need to first put them in a head-to-toe fashion. Right now they're not head-to-toe fashion. Head-to-toe fashion means that we're gonna take this Fu, bring it down parallel until the tail of Fu meets with the head of Fv. Okay, so that would look something like this. Let me draw this here. Fv. So okay, and then you have here, this is F equals 500 Newton, and this is Fv, and this is Fu. So if we keep the same colors, then this is Fu, this is Fv. Okay, let me write Fv here, and this is Fu, of course. Okay. Now we know the angle between V and U, right? And since we have moved this parallel, so if we were to draw this like this, that angle is 70 degrees. So since we're moving Fu parallel to itself, it'll always make that 70 degrees. So hence this angle is 70 degrees, right? We already know this angle 45 degrees, which is given right here, right? Now, so 70, 45, so this should be 65. Alright, so we know three angles and we know one of the sides. So now we use the sine rule, which says a side divided by the sine of angle opposite to it. So the sine of angle opposite to it, so that's 70 degrees. So 500 divided by sine 70 is equal to Fv divided by sine 65, right? So sine 65. So all that's required now is simple rearrangement. Fv is equal to 500 times sine 65 degrees divided by sine 70, and that comes to about 482 Newton. Okay. Similarly, finding Fu, so we use the known quantity 500 by sine 70 is equal to Fu divided by the sine of the angle opposite to Fu, which is sine 45. And then Fu is equal to 500 times sine 45 divided by sine 70. Okay. And this comes to 376 Newton. Okay, so what this means is if you need a resultant of 500 Newton in this direction of 500, then you need to pull Fu in this direction with 376 Newton and Fv as 482 Newton. Then you'll have F, the resultant, as 500 Newton. That makes 45 degrees angle with Fv. Okay, to summarize the steps, Fu, Fv, we don't know, we need to find those. We're given F equals 500 Newton and these angles. Move Fu parallel to itself until they're in a head-to-toe fashion, until it is in head-to-toe fashion with Fv, and then F, the resultant, becomes the closing side of the triangle. Then apply the sine rule. 500 divided by sine 70 is equal to Fv divided by sine 65. 500 divided by sine 70 is equal to Fu divided by sine 45, and you get these two answers, Fu and Fv. Okay, hope that helps. Thanks. Bye bye.